In this section, we'll be talking about analysis with TShark, and I really want you to understand what the capabilities of TShark are and also see those being used. So we're going to flip back and forth pretty frequently between some slides where I'm listing the commands and talking to you about what those do and what they mean, and then the demo environment where I'm actually showing you the commands and actually using TShark to capture packets and filter through those packets and run some statistics and so on. So we're going to go through all the different features associated with TShark, and you'll actually see me using it as you might want to use it. Now, as stated before, TShark essentially is terminal Wireshark. That's what the T stands for. So when I say terminal, I'm saying command line based. Now, the great thing about it being a terminal version of Wireshark is you get a lot of the features of Wireshark with it kind of by default. First of all, it's installed with Wireshark by default. So if you just click next, next, next through the installation, you're getting TShark anyway. So that's pretty cool. Not only that, but it also uses Wireshark's protocol dissectors, the same dissectors that we discussed earlier and talked about how protocols are like languages and how a tool dissects a packet and shows you all the broken out fields. Well, TShark can do all that as well because it uses those same dissectors. This is a really distinct benefit over something like TCP dump, which doesn't have such a wide array of dissectors. And as a matter of fact, as you'll see if you watch the TCP dump section, TCP dump doesn't really do a lot for the dissection of layer 7 protocols at all. You're on your own for most of those. But for TShark, it does do that dissection in the same way that Wireshark does because it's essentially using the same code to process and interpret those packets, which is one of its real strengths. TShark also provides a baseline set of statistical features very similar to the feature set provided in Wireshark. So you can do things like look at the list of conversations or a protocol hierarchy or view TCP streams. You didn't used to always be able to do those things, but now in TShark you can, and you can all do that from the command line, which is pretty cool. Finally, TShark is available on most operating systems that you're probably going to be using. It's available on Windows, Mac, and Linux, which makes it pretty ubiquitous. You can find it in most places, and if you have the ability to install software, it's a pretty easy installation too. We're not going to cover installation of it here because if you installed Wireshark, again, you probably have TShark already. If not, you can go back and review that section. That said, let's go ahead and jump into this and learn a little bit more about TShark, its capabilities, and what all it can do for you. The base capability of TShark is all about reading and writing data. And if you just start up TShark with no additional command switches, so if you just type TShark, it's going to operate in packet sniffer mode, which means it's going to collect packets off the wire and dump those to the screen so you can see them. Now, I can't think of a ton of use cases where that's super useful to me. Most of the time, I want to save those packets off and store them for later analysis or maybe some filtering, and we'll talk about that. But just by default, it'll operate in this baseline packet sniffer mode, dumping to the screen, but there are a few options you can use to tweak that. One of those options is the ability to specify an interface, and this is something you may have to do pretty commonly, especially if you're on a system with multiple interfaces. So to list the interfaces on the system on Windows, use the -D switch, and it'll give you each interface on the system along with a number that can be used to reference it. If you want to capture packets specifically from an interface that's on that list, you specify the -I switch and the number of the interface you want to use. So if it was interface 2, it would be TShark-I 2. And that would get just those packets. Now, as far as reading from the wire, that's how you would do that. But what about if you want to read from an actual PCAP file or a PCAP-NG file, which is what you're going to do for most of the exercises in this course, of course, because I'm providing you packet capture files to read out of. And that's pretty simple. It's just the -R command and the file name that you want to read from. So tshark-r filename.pcap or .pcapng, of course. Finally, the scenario I mentioned just a moment ago is writing TCP dump output to a file, and you can do that with the -W command. So in this case, it would be tshark-w filename.pcap. Of course, in this case, filename.pcap is what the name of the file would be. It would be saved in the current directory that you executed tshark from, and in this case, it would be capturing packets off of the wire and dumping those into this file. So this is all the baseline functionality as far as how do I capture packets off the wire, how do I read existing packets, and how do I write those things out to a file. Now you can do some interesting things here too. So you can actually read from one file and write to another. That's not shown here. We'll go through an example of that here in a moment. But I can read from one PCAP, apply a filter to that, and then write it to another PCAP, which is a really common workflow and perhaps one of my most common workflows when I'm using command line packet analysis is filtering a file down to something that's a little more useful or something more easy to open up. So that's enough talk about that. Let's go ahead and flip on over to the lab environment. I'll actually show you some of these commands in action. I pulled up the Windows VM here, and that's where I have TShark installed. This is the same VM we've been using for all the demos in this course. So TShark was installed when I installed Wireshark. Now, to make sure TShark is functional, the easiest way to do that is just to type TShark-V, and that's going to output the version information, and that means Wireshark was able to, TShark was able to run, and we see a little bit of information about that. So go ahead and clear that out of here, and let's talk about some of the commands we've talked about. So first of all, I said if you just run TShark as it is, you're just going to start capturing packets off the wire. And in this case, it's going to, since this is a virtual machine, prompt me to enter a password, so I have permission to do that. And then you're going to see all these packets just start capturing. Of course, this is not insanely useful. You can't do a lot when these packets are scrolling like this. So by just dumping them to the screen, we're not really getting too far. So I'm going to go ahead and terminate this and clear the screen out, and let's try something a little better. Now, of course, as I said, we can also specify an interface. So if I do TShark/D, it'll tell me two interfaces I have to capture from. And if I want to specify one, I could just do TShark-I1, and that would specify, in this case, my Ethernet adapter. I don't really want to capture off the Bluetooth network connection here. Now, one thing I would recommend getting in a habit of is always specifying your interface. And I generally almost always do, just because you never know what's going to change, and you never know what system it might pick, what interface the system might pick as a default interface. And I always want to take that variable out of the equation, make sure I'm getting the exact packets I want to be capturing. So I pretty much always run the -D command to get a list, and I always specify one. So you'll very rarely see me run TShark without TShark-I. Now, I may do it a couple times in this course just for the sake of brevity, but again, in practice, I'm mostly always specifying my interface. And of course, if I do that here, you'll see I'll get similar results, just more packets captured from the wire. Now, the next thing is, what if I want to read from a packet capture? And this is something we've talked about too. And to do that, we simply specify TShark-R, and I have some packet captures here. This one is one we've looked at before, http espn.pcapng. And if I try to open that, sure enough, it will open. Again, this is just dumping to the screen, and this happens to have a lot of packets in it, more than are really useful to be able to analyze like this without applying some specific filters. So it's just going to keep reading that out until it gets to the end, or until I manually stop it by pressing Control-C, which is what I've done here. Now, finally, one other thing I can do is issue the previous command, and let's say instead of dumping these packets to a screen that I'm capturing off of the wire, I want to save those to a file. So I'll just append the -W command onto this particular capture command, and let's just call it ppa test.pcap. And notice it's not going to dump all those to the screen anymore, which is really great because that was kind of annoying. But it does count, and that count you see incrementing there at the top left right here. This is the number of packets that have been captured. So that's pretty useful. It gives me a sense of, am I capturing data at all? What is the rate at which I'm capturing data, and so on. Of course, if this remained at 0, I know I'm not getting any data. If it shot up to 100,000 in a matter of a couple seconds, I'm probably getting a lot of data, and maybe even too much data. When I'm ready to stop this, I just hit Control-C. And when I do that, I should now be able to open up the file that I just mentioned. Yep, TShark-R, ppa test.pcap. And sure enough, here it is. So those are all the packets that I just captured. So pretty straightforward, and that's what you need to know in terms of being able to capture, read, and write packets using TShark. Next, I want to show you how to make the TShark output a little bit more manageable with a few options it has. You may have seen that the default output for TShark is a single line which summarizes the the packet captured information. So this is very similar to the Wireshark output, but it's somewhat unique to TShark, and it's designed to fit on a single line. But you can manipulate this a little bit more and make it look more like the Wireshark output you're used to. A couple options here. First, I'm going to show you the -C option, which will limit the number of packets shown if you only want to see a few of them. Next, I'll show you the -V option, which will show you what is the equivalent of the packet details window in Wireshark, and then the -X option, which will show you the equivalent of what is the packet bytes option in Wireshark. Now, if you'll remember, we just captured a file, and it was called PPA test.pcap. And if I just try to read this just like this, it's really just too many packets to do anything with. It's just overwhelming. So I want to slow that down here, and I want to be able to just show just a few packets. Let's try that. So to do that, I'm going to use the C command. So I'm going to, actually, let's just do this, tshark-r PPA test.pcap, and I'm going to do -C1. And see what that does. It shows me just a single packet, and you can increment this as much as you want. I can do C3 and it'll give me 3 packets, and C5 and it'll give me 5 packets. Now notice, as I said, the default output mode for TShark is a simple individual line that provides somewhat of a summary of the communication, and this is information you're familiar with if you already looked at the Wireshark sections. On the left we have the packet numbers, so these are numbered starting with 1 and incrementing each time. We have the timestamp being used. I believe this is referenced time since the beginning of the capture. Then we have the traffic itself, and we have a definition, we have the direction of the traffic, so from source, so a source IP address to a destination IP address. Of course, see we have an IPv6 one here, which is pretty cool. And then we have what is essentially the equivalent of the protocol column, which tells us what protocol is in use, and then the info column we would see in Wireshark in the packet list window. So that's going to be specific based upon the dissector that's dissecting the protocol in use. So we see here, looks like we have some just standard TCP data. We have some MDNS as well. Not too much exciting in this little capture. As a matter of fact, let's go ahead and open up one of the HTTP examples we had and get the first 5 of those. Let's get the first 6 of those. Whoops. Not 56, 6. There we go. And so we see here we have DNS here at the top. We have some TCP data setting up a 3-way handshake, and then we have HTTP and HTTP GET. So this is really the same information you would see in the packet list window, just kind of optimized for display in TShark, so it's a little bit easier to see. Now, that said, let's go ahead and try to organize this a little bit better. Let's look at an individual packet, and let's say we want to get more detail about that specific packet. We can do that by applying some of the options we discussed just a moment ago, the V and X options. So let's start with the V option. By putting capital V here, I will get what is equivalent basically to Wireshark's packet details window. Now notice I put -V next to the R, and you can do that. You can put that pretty much anywhere. You can't put it after the R because after the R it's expecting the argument of the file name. But I could do this a couple ways. I could do -V -R, or I could do whatever, but in this case, I like to generally append them with the -R command, so I'm not just typing a bunch of unnecessary dashes. So when I do this, notice we're going to get a lot more information. We're going to get what is essentially the fully expanded version of the packet details window. So notice we start with our frame data here. We have our layer 2 Ethernet data. We have our IPv4 data starting around here. We have our UDP data. This is a DNS packet, so it's on UDP. And then we have our DNS data, our layer 7 data here as well. So we see all of that fully expanded. Not the most efficient way to look at that because it is shown in that way by default, but it is one option, one way to look at that data. I do want to show you one more little trick here that kind of extends the -V option and make it a little bit more useful. And to do that, we're actually going to get rid of -V. And let's say, if I run -V, it's going to give me this fully expanded output of every single header. And what if I don't want that? What if I only want an individual header? Like, let's say I only want, I don't know, the UDP header. Well, we can actually do that by using a different command line argument. So we're going to get rid of -V and put in -O and specify UDP, and what that's going to do is say, hey, only output the packet details information for the UDP header. And notice that's what we get. We get what is essentially, if you were looking at Wireshark, the packet details pane with everything collapsed except for the UDP header. So we still have, frame 1, Ethernet, Internet Protocol v4, and DNS, but they're collapsed, and we only have the UDP protocol expanded. So we can do this with any number of protocols here. I believe we can do this with DNS as well, sure enough, and we get just the DNS information. So this is a lot better way to drill down into specifics of the packet. I generally, for my purposes, hardly ever use -V unless I really just want to dig into one packet holistically. I almost always use -O and then specify the packet header that I want to dig down in. This is pretty cool. This is a feature not a lot of people realize is there. They think you have to expand the whole thing, and they end up just not doing it or exporting it to Wireshark, what have you. You can list the specific protocol you want to dig down into and go from there, which is pretty darn cool. So finally, the one thing we don't see here that we would see in Wireshark are the packet bytes. So we can pull those up pretty easily. I'm going to switch back here and, whoops, there we go. Replace this -v with a lowercase x, and that will tell Wireshark to dump, or excuse me, TShark to dump out the packet bytes of the packet. So this is what you would see at the very bottom of the screen using the default Wireshark view if you want to dig into the individual bytes. Again, this is the least abstracted view into the data.